We are going to look at solving more complex simultaneous equations. And this topic is very intrinsic to your topic because questions always come, and it's important that you learn this as well as a matter of interest. Let's have a look at how this can be done. And I'm recommending you read through the textbook that I've indicated at the beginning of this slide, and it is on page 220. If you're using any other textbook, I'll look for where it says more complex simultaneous equations. How does this work? Let's go through this very quickly. I will use two basic understandings that we're going to look at in every of these. Bear in mind, two methods can be used very commonly. Two methods. There is a substitution and also what we call elimination method. So these are the methods we broadly look at as we journey through this topic. Very important methods, and they're going to help you solve simultaneous equations. Now let's look at our very first examples. Simultaneous equations. Let's have, for example, 4x plus 3y equals 27 and 5x minus 2y equals 5. These two constitute a system of simultaneous equations, and we need to find a solution that is common to both these equations. When you inspect the equations, you discover very critically that they have terms in x, terms in x, terms in y, terms in y, and they're constants, okay? So it's very important to qualify that. So at the end of this day, we want to find value for x. We also want to find value for y. This is the end product. Are we happy with that? So bear that in mind. Let's start the process. One of the things we're going to look here at is, let's use a method of elimination. Can we get to a point where what we mean by elimination, which is one of these methods, we want to get rid of either this term in x and that term in x. In order to achieve that, we must make these two equal. You understand that? Or if we choose to eliminate this term in y, we must make these two equal. How do we achieve this? Simple and straightforward. Let's go to the next stage. In order to achieve that, we are going to let's do this. I want to get rid of the terms in y. So I'll find a factor that if I multiply by that, this number will become 6, and that will become 6. Can we do that? So I label this as equation 1, this as equation 2. So I'm going to multiply equation 1 by, I'm going to multiply equation 1 by 2 to make this 6. So I go like 2 times 4x plus 2 times 3y equals 14, that's 54. That is the equation 1. I've multiplied it by 2. This equation 1 has been multiplied by 2. So to make this equation 2 6, I'm going to multiply it by 3. So I go 3 times 5x minus, because it's a minus there, minus 3 times 2y is equal to 10. No, so 15. 15, I beg your pardon. 3 times 5 is 15. It is 15. So equation 2 has been multiplied by 3. Can you see that? Very important. Now, once you do that, subtract these two equations. When you compute completely, what is 2 times 4? It is 8. So that is now 8. What is 5 times 3? 5 times 5? 3 times 5? It is 15. So you put 15. Can you see that? Becomes 15. Comes 15. Let me write it properly. That is 15. So what is 3? 2 times 3, it is 6. And there we also change it. Yeah? So it is 6. It is 6. Now these two must be subtracted. I must subtract these two equations. So I take away 8. What I do now is 8x take away 15. Sorry, I beg your pardon. I just add. You are going to add these two equations. Add the equations. Just add the equations. Add the what? The equations. Add them. Simply add them. Add them. Why? Because here, when you add these two, they'll cancel out, become 0. So you end up with the following, which is 8x plus 15x. It is 23. 23x. Okay, when you add that, it is 69x. Correct? Yeah, you end up with 23x is equal to 69. So from there, when you have 23x is equal to 69, what you have is simple and straightforward. You have a value for x. Yes, you have a value for x. If you want, you have a value for x. So once you have a value for how many 23s can go in there, it is certainly 3s. It is 3. You have a value for x. Once you have a value for x, now use substitution. Okay? Use what? Substitution. In any of the equations, in any of the two equations. Okay, in any of the two equations. Can you follow that? Which equations? Equations 1 or equation 2, which is here. you can now substitute in any of these, either that one or that one. Substitute what? The value of x. Okay? Because now here we have the value of x is 3. So if I pick up now one of the equations, say 4x plus 3y is equal to 27. Which equation is this one? Let's go back and check. That is equation 1. If I now put the value of x, which is this one, I put it in that equation, it becomes 4 times 3 plus 3y is equal to 27. So 4 times 3 gives me 12. So what I have now is 12 plus 3y, isn't it? 12 plus 3y is equal to 27. Okay, you see that? This is the place. You have got to watch carefully. You see that? This is the stage. 4 times 3, because the value of x is 3, according to here, the first calculations. So we have now 12 plus 3y is equal to 27. This is why you have this. Once you get to that stage, simple and straightforward, you want to get rid of that to go to the other side, and once you do that, it becomes minus 12. So what you have now is 3y. Remember the previous lesson? 27 minus 12. So what you have there now, it is 5 there and 15. So once you have that one, you're going to divide throughout by 3. So dividing throughout by 3, you are going to have your answer as 5. Y is 5. So once you work it out, y as 5, you have two values now. X is 3, y is 5. So your final answers will be x is 3 and y is 5. You have now solved a system of simultaneous equations. So the key point to understand about system of simultaneous equations is you have to identify between these two equations which terms you're going to eliminate first, and then after you've worked out the value of one variable, then you can use it to substitute in one of the equations, either of the equations, because it's important to understand that when the word equation is used, it means it is equal on the left side and on the right side. And both these equations, they share the values. And the values we have worked out on this one, you can see it's x and 3. If you're going to plot this one on the graph, it's x, comma y, which is 3, comma 5. But that's not the topic here. I hope that you've understood the way equations are solved using a system of simultaneous equations using elimination and substitution. They can get more complex than this. And what I recommend now is, if you're using the book that we have on this topic, you should try exercise 13M. Exercise 13M, and try and solve this. Let me just probably work through one of the equations. In case you don't have the books, I want you to do the following. This is going to exercise. Okay, is your exercise. And this is exercise 13M. Okay. 13n. I want to teach through this material. Solve for me the following. 2x plus 5y is equal to 15. Then I use 3x minus 2y is equal to 13. That's question 1. Solve that. Question 1, solve that. And also I'd like you to attempt the following. Question 2, 3x plus 2y plus 2y. Where was I now? Plus 2y is equal to 2x plus 7y is equal to 13. Try those ones. Try those ones. And I also want you to do, that's question 1, 2, question 3. Solve the following as well. I'll just do 4x minus 3y is equal to 4x plus y is equal to 7. Solve that system. Number 4, y plus 2x is equal to 4. 3x plus 2y minus 2y is equal to 6. Mind you, when you get a system like this one, you have to rearrange. Think, okay? Think about rearranging. You should be able to rearrange the order, okay? Don't just think, because think about rearranging. Think about rearranging. That's hint. Let me just say hint, rearrange. Forget this. I'll just hint. The hint here I can give you is hint for question 4 is rearrange. I think that's a better way to guide you. Rearrange. Okay. Then I also want you to do the following. That's what question is that? Number 4, number 5. Is that number 4, number 5? Number 4, number 5. Not all these questions are in the book. But is there a button? Okay. Hello? Are you ready now? Oh, excellent. Now, Oprim,